Hello. In today's lesson, we're going to be learning about divalent compounds. Now, in a divalent compound, there are two possible charges for the cation. It's easy to identify which elements are divalent compounds by looking on the common ion sheet provided to you. So, if you have not done so already, please open up the common ion sheet as we go through today's lesson. In addition, you may want to open up the assignment on divalent compounds because we'll be completing some of those examples together throughout the lesson. So as we get started today, the first thing that I want to mention is what is meant by the term divalent cation. Well, let's go back to our chapter on periodic table. You might remember writing out electron configurations for elements. In bonding, we learned that elements, in this case cations, will lose electrons in order to empty out their valence electrons, their outermost level of electrons. Well, in the case of some elements, there are different amounts of electrons that can be emptied out. And in that process, we wind up with two or more possible charges for an element. Now, in the case of tin, you might see on the common ion sheet that the possible charges are a +2 or a +4. Meaning tin could either lose 2 electrons or lose 4 electrons. Let's take a look at how that happens. So if we look at the electron configuration for tin, we'll notice that in our outermost level, we have 5s2, 5p2, meaning we have 4 valence electrons. If only the electrons in the 5p2 orbital are lost, we'll wind up with a +2 charge. However, if all 4 valence electrons of tin are lost, we'll wind up with a +4 charge. The only divalent ions that you are responsible for knowing are the ones that are on the common ion sheet. There are, in fact, many more on the periodic table, but we're going to be focusing on those examples only. Let's take a look at how we put this into practice. So, in order to give you a visual for what's happening, let's take a look at 2 examples of ionic compounds that can form with tin. First, let's take a look at tin with a +2 charge. In this case, a +2 charge with tin will require 2 chloride ions in order to form a neutral compound. However, if we look at something like tin 4 will require 4 chloride ions in order to achieve that neutral charge. Remember, when we're dealing with ionic bonding, our ultimate goal is to form a compound that has a neutral charge. And we do that by changing the number of positive and or negative ions in order to achieve that balance. Let's take a look at some naming and writing formula examples. Okay, when you look at the instructions for writing the formula for a given name for a divalent compound, it might look familiar, and that's because we're very much going to follow the same process that we did for simple binary compounds. So in the first part, it says identify the charge of both the cation and the anion. And then finally, when necessary, we're going to find the least common multiple in order to balance the charges and eliminate those positive and negative ions. Reduce when possible simply means that if we have 2 cations and 2 anions, we can reduce them to 1 of each. So the first thing that I want you to notice is that there are 2 names for all of these divalent cations. There's what we call the common system name and the stock name. We're going to start off by looking at the stock name. That's the one that has the Roman numeral. The Roman numeral indicates the charge on the cation. So in this case, copper with a Roman numeral 2 means that we have copper with a +2 charge. Chloride, that part is going to be just like we saw in our previous lesson. Because chloride is in group 17 on the periodic table, it will have a -1 charge. Putting these two ions together, you'll see that we need 2 copies of our chloride in order to balance out our copper. So our final answer will be CuCl2. Now, in that middle spot, what I'm asking you to do is to write the other name for copper 2. So if you look on the common ion sheet, you'll find out that the other name for copper 2 is cupric. So in this spot, I would like you to write out cupric chloride. Here is our stock name, here is our common name, and here's our formula. For our second example, I started you off with the common name. Now, in these cases, my recommendation is to work backwards first and figure out what the stock name would be. So for stannous, we'll learn that that is tin 2, the lower charge of tin. Sulfide is going to remain exactly the same. Now I can go and write my formula based on this. So tin 2 means I have a tin ion with a positive 2 charge. Sulfide, group 16 on the periodic table, negative 2 charge. And just like we saw when we did simple binary compounds, positive 2 and negative 2 will cross out. You may notice something about the endings for the common names. They all end in either OUS, us, or IC, ic. There is no set charge associated with the ending. However, you will notice, and through practice you'll pick up on, the fact that the lower charge, whatever that charge is, gets the OUS ending, and the higher charge gets the IC ending. So if you notice, in the case of copper, copper could be 1 or 2. Copper 1 is cuprous. Copper 2, which is what we have here, is cupric. In the case of tin, tin could be 2 or 4. In the case of tin 2, we have stannous. If we had tin 4, we would have stannic. Let's take a look at some of those homework problems. So if you notice, I divided up into problems 1 through 6 and 6 through 10. In problems 1 through 6, you're given the stock name, meaning the name that has the Roman numeral. So the first thing that we can do is write out what the common system name is just by looking over one column. So for copper 2, we're going to have cupric, and then we'll just recopy the second part, iodide. Now, copper 2 means we have copper with a 2+ charge, iodine, group 17 on the periodic table, -1 charge. So putting these together, we'll need 2 copies of the iodine in order to balance out the charge on copper. So our final answer will be CuI2. Let's take a look at our next example. We have lead 4. That's the higher charge. Lead could be 2 or 4. So lead 4, we're going to call plumbic. We'll keep the nitride just as it is there. Lead 4 is Pb with a +4. Nitride, group 15 on the periodic table, -3. So here we need to find a least common multiple. The least common multiple between 4 and 3 is 12. So we need to get lead up to 12, we need to get nitride up to 12. If lead has a 4+ charge, that means I'll need 3 copies in order to get to 12. Nitrogen, which has a -3 charge, I'll need 4 copies in order to get to 12. So my final answer will be Pb3N4. Let's take a look at our next example. We have tin 2 nitride. Tin 2 is the lower charge, which we call stannous. Tin will have a +2 charge. Nitrogen or nitride will have a -3 charge. In this case, our least common multiple is 6. So we'll need 3 copies of tin and 2 copies of nitride in order to get up to 6. Example number 4, we have iron 3 chloride. Iron 3 is the higher charge for iron. So we'll have ferric chloride, means iron with a positive 3, chlorine group 17, negative 1 charge. In order to balance out the positive 3, I'm going to need 3 copies of the negative 1. And the last example where we start off with the stock name is copper 1 oxide, also known as cuprous oxide. Copper plus 1. Oxygen, which is in group 16, has a negative 2 charge. I'll need 2 copies of the copper in order to balance out the oxygen. So Cu2O. 2 copies of positive 1 in order to balance out the negative 2. In our next 5 examples, we're starting off with the common name. So my advice to you, again, is to work backwards first and go to the stock name. So cupric means that we have copper with a positive 2 charge, or copper 2 chloride. Again, you figure that out by looking on your common ion sheet, moving over 1 column to the left. On this part, we have copper with a 2 plus charge, chloride with a 1 minus charge. I'll need 2 copies of chloride in order to balance out my copper. The next one, mercurous. That is the mercury 1 ion. Mercurous nitride. Now, you'll notice that mercury 1 on your common ion sheet is kind of an anomaly. Even though it has a positive 2 charge, you'll notice it also has a 2 subscript. So it's a weird ion in that it pairs up with itself all of the time, forming this Hg2 with a 2 plus charge. Nitride has a negative 3 charge. And in order to balance these out, we're going to need 3 copies of the mercury 1 and 2 copies of the nitride. So Hg2, because we need 3 copies of this thing, we're going to put that in parentheses and put a 3 there. Nitrogen we'll only need 2 copies of in order to get to our least common multiple of 6. This is a difficult one. Let's take a look at the next one. We have manganic iodide. Manganic is the higher charge for manganese, a 4 plus charge. So we'll have manganese 4 iodide. On this side, we're going to start off with Mn plus 4, I minus 1. We need 4 copies of iodide in order to balance out the manganese. So we'll get MnI4. For the next one, plumbous oxide. Plumbous means we have the lower charge of lead, also known as lead 2. On the right side, we're going to start off by writing our lead 2 plus. We have our oxygen, which is minus 2, plus 2, minus 2 cancel each other out, so we're left with just PbO. And finally, our last example. We have cuprous. Looking on your common ion sheet, you'll find that's the lower charge. So copper 1 fluoride. Copper with a plus 1, fluoride, group 17, minus 1, plus 1, minus 1 cancel each other out. So we're left with CuF. If you have questions, please please consider rewinding the video and watching these parts over again. If you're good to go, please finish up this part of the assignment on name to formula. In our next part, we're going to be learning how to write out the chemical name when given the formula. This part is a little more complex because you can't simply look at what group an element is on the periodic table in order to figure out what charge it has. In this case, we're going to have to do some math in order to work backwards. So let's take a look at the instructions. It says to identify the charge on the anion, that's the second element, first. This is much different than what we've done previously. The second is to determine the cation by dividing the total charge from the anions by the number of cations. So I'll show you what that means. Last, we're going to identify the Roman numeral associated with that charge. So we're only going to have Roman numerals of 1, 2, 3, or 4. So just showing you 1, 2, 3, 4 as Roman numerals. I, 2 I's, 3 I's, and IV for number 4. Okay, let's take a look at some examples. So in this case, we have Pb3N2. We want to identify the charge on the anion, the second element, first. So that's the N2 charge. Nitrogen, which is in group 15 on the periodic table, has a -3 charge. There are 2 copies of nitrogen. So the entire charge on the right side of this compound is -6. -3, 2 copies of it, -6. That means on the left side, we have to have a total charge of +6. Now, we have 3 leads on the left side. What charge would lead have to be in order for 3 copies of it to add up to +6? Well, that would mean we would need lead with a +2 charge. 3 copies of lead with a +2 charge will add up to the +6 charge that we're looking for. Once you figure out the charge on lead, you can write out the 2 names. So lead with a +2 means we have lead 2 nitride, also known as plumbous nitride. Okay, let's take a look at our second example. In our second example, we have phosphide. Phosphide on the periodic table is located in group 15, meaning it has a -3 charge. There's no subscript down here, so that means I have 1 phosphide. That makes the total charge on the right side -3. The total charge on the left side is also going to be a 3, this time +3, in order for them to cancel out. Now, I have copper, 3 of them, giving me +3 as a charge. That means each one of my coppers has to be +1. This number tells me the number of copper ions that I have. This tells me the total charge. 3 things adding up to +3 means they're +1 each. So I have copper, 1 phosphide, also known as cuprous phosphide. If you do a problem and you get a charge for your ion that's not one of the charges on the common ion sheet, then you probably did something wrong. So your result, lead +2, should be one of the possibilities. If we were to do our math and come up with lead +5, we would know that we did something wrong. Let's take a look at our last example. In this case, we have tin combining with sulfur. Sulfur is in group 16 on the periodic table, meaning it has a -2 charge. I have 2 copies of sulfur, That means the right side is going to have a -4 charge. In order to balance that out, the left side has to have a +4 charge. This time, I only have one tin. So there's no subscript here, meaning this tin is carrying a +4 charge. So I have tin 4 sulfide, also known as stannic sulfide. Let's take a look at some of these homework problems. In our first example, we have copper and we have sulfur. Let's divide this up. So our sulfur, which is in group 16 on the periodic table, has a -2 charge. There's no subscript here, so that means I have a 1. And that tells me that the entire right side is equal to -2. That means the entire left side has to be equal to +2. I have just one copper. There's no subscript here, so I have just one. That means that one copper has the +2 charge. So in this column, I'm going to write my stock name. In this column, I'm going to write my common name. So my stock name is going to be copper. Because it has a +2 charge, I'm going to put a Roman numeral 2. And finally, the ending on that, sulfide. The other name for copper 2, according to my common ion sheet, is cupric. So my common name is cupric sulfide. Let's look at example number 2. In this case, we have bromine. Bromine is located in group 17 on the periodic table. So it has a -1 charge. I have 4 copies of bromine, so 4 times -1, that's -4. On the left side, I have to have +4 to balance it out. And I have just one lead getting me to +4. So that means my lead must be lead 4 bromide. The other name for lead 4 bromide is plumbic, because it's the higher of the two. So we have plumbic bromide. Let's take a look at our next example. We have lead and we have nitrogen. Nitrogen is in group 15 on the periodic table, meaning it has a -3 charge. I have 2 copies of that nitrogen, so 2 times -3 is -6. On the left side, I have to have +6. But now, instead of one thing, I have 3 things. So in order to get to this +6, I have 3 different ions, or 3 of the same ions, actually. So I have 3 leads. And each of them has to be a +2 in order to get me to a +6 overall. So lead with a +2, lead with a +2, lead with a +2, all add up to be +6. How did I know I needed 3? Because of the 3 right here. So I have lead 2, because of the +2 here, lead 2 nitride, also known as plumbus, the lower charge one, plumbus nitride. Let's look at example 4. So for iron, remember, according to your common ion sheet, iron has 2 possible charges, either 2 or 3. So we should be looking for either 2 or 3 as our answer here. So let's break this down. We have oxygen first, start on the right side. Oxygen has a -2 charge. It's in group 16 on the periodic table. I have 3 copies of oxygen, -6 overall. It means the left side is +6. I have 2 things getting me to +6. So the 2 here. 2 things getting me to +6. So that means they are +3 each. So in this case, I have iron 3 oxide, also known as ferric oxide. In my last example, I have iron once again. In this case, iron should end up as either a 2 or a positive 3. So those are the two possibilities that we have for iron, positive 2 and positive 3. So I'm going to break this up. We have iodine, that's in group 17 on the periodic table, -1 charge. There are 2 copies, -2. That means the left side has to be positive 2. This time, because there's no subscript on iron, one iron has a positive 2 charge. So I have iron 2 iodide, also known as ferrous iodide. Okay, that wraps it up for divalent cations. I hope everyone has a great week. Please finish this assignment and submit it on Schoology when you're finished. If you have any questions, please stop by office hours. Bye, everyone.